In this lesson, we will explore the concept of factoring polynomials and factoring polynomials using various methods. So let's start with factoring. What is factoring? Factoring is expressing a polynomial as a product of polynomials, the opposite process of expanding, distributing, and multiplying. So this visual 2 times x plus 5, to expand that, we take the 2 and distribute to each of the terms inside the bracket. So 2 times x, which is 2x, 2 times 5 is 10. So now if we went the opposite direction, we would be factoring. We would be looking at 2x and 10 and looking to see what is a common factor between 2x and 10. Well, the common factor between those two terms would be 2. So if we divided 2x by 2, we'd result with x. 10 divided by 2 would be 5. So as you can tell, expanding would be one direction. Factoring is expressing that polynomial as a product of polynomials. First factoring strategy that we're going to observe is common factoring. Common factoring, with any factoring, always check to see if you can common factor first. That's the first thing for any kind of factoring question. Always look to see, do the terms have a common factor? You must find what that greatest common factor is and divide each of your terms by that greatest common factor. So let's factor fully the following. So in A, we have 3x plus 12. So with 3x plus 12, we want to look at both 3 and 12 and think of what is the greatest common factor, not just a common factor, but the greatest. So what you're looking for is, what is the largest number I can divide out each of the terms in my polynomial? In this case, between 3x and 12, we can factor out a 3. So if we factor out a 3, that greatest common factor goes outside the bracket. And then I'm going to show with the first example, we would take each of the terms that we started with and divide it by 3. You do not have to show this every time. I'm just going to do that for the first example so that we see how we factor out a greatest common factor. And then we simplify. 3x divided by 3, which we know is x. 12 divided by 3 is 4. Now, a quick way to make sure that we have factored properly is by expanding, going the opposite way. We know that if we took 3 times x, it would be 3x, and 3 times 4, which would be 12. Now, in this case, it was a number that was common between both terms. Sometimes it's more than just the numerical coefficient that you can factor. Also, the variables in our terms are common. So looking at 4x squared y plus 8xy squared, it's a good idea to remind yourself that those terms that have a variable with no exponent shown, it is always 1. So start with the numerical coefficients. What is the greatest number I can divide out of both 4 and 8? You might think it would be 2, but 2 is not the greatest. Yes, you can divide 4 and 8 by 2, but there's a larger number, which is 4. So you always have to decide on the greatest common factor. So 4 is common between both of those terms. Then we look at our variables. If you notice, we have x squared and x. Now, the first term has 2 x's. The second one only has 1. So the only common x is one of them. Again, it's a common factor if all the terms have that factor. Then looking at both terms, they both have a y. So we can see we have y and y squared. Well, the greatest common factor there would just be a single y, because the first term has 1 y, the second one has 2. One of those y's is common between both. Now looking at 4x squared y, so I will show for these very few examples that once we figure out what the common factor is, we take both of those terms and we divide it by the common factor. Okay, so we're left with 4xy. 4 divided by 4 is 1. X squared divided by x would be simply x. Y divided by y would cancel out. So keep that in mind. Those, and you're left with 2 minus 1 on that exponent of x. Doing the same thing between 8 divided by 4, we know that's going to be positive 2. Those x's cancel out. And subtracting those, because we're reminding ourselves again, exponent rules. When you divide powers with the same base, you subtract those exponents. So 2 minus 1 is y to the power of 1. You will quickly know whether you came up with the greatest common factor or not. That inside your bracket, if there is still something common, you did not come up with the greatest common factor. You might have come up with a common factor, but not the greatest. So looking at C, we're looking at the numerical coefficients first. So what is the greatest common factor that I can divide out of 8, 6, and 4? In that case, it would be 2. Now, looking at the variables, again, it's common if each of the terms in your polynomial have that variable. So the first term is x cubed, second one x squared, and the third one x squared. So the most common is x squared that we can divide out of each. The first term, 8x cubed, does not have a y, so it is not common amongst all the terms. So we can close up that bracket, and then we go back and we divide. We take 8x cubed divided by 2x squared. And then we take negative 6x squared y squared divided by 2x squared. And then 4x squared y divided by 2x squared. So simplifying, then we leave the common factor, greatest common factor up front. 8 divided by 2 is 4. X cubed divided by x squared is simply x. Minus negative 6 divided by 2, which is negative 3. X squared divided by x squared cancel out, and we're left with y squared. 4 divided by 2 is 2. X squared divided by x squared cancel out, and we're left with y. So keep in mind, those fully simplified. Using exponent rules, x squared divided by x squared, you keep the base, subtract the exponent. X to the power of 0 is 1. So this is why we simply say they cancel out. Okay, that's the first method of factoring would be common factoring. Always look for a common factor. The second method is simple quadratic trinomial. So factoring a simple trinomial. So when factoring simple trinomials, you need to find, if you look here, two numbers that add up together to equal to b, which is the coefficient in front of x, and then two numbers that multiplied up together to equal c, our constant. So looking at the first example, x squared plus 7x plus 12. The reason why this is considered a simple trinomial, so we know trinomials have three terms. The coefficient in front of x squared is always 1 with a simple trinomial. So we need to figure out two numbers, so added together to equal to 7, which is our b. Those same two numbers multiplied together equal to c. So again, keeping in mind, this is x squared plus bx plus c. So b would be the 7, c is the 12. So this is where we have to refresh and know our multiplication table quite well. Start with your product, thinking of two numbers multiplied together to give you 12. So there's many options. However, the same two numbers that are the product of 12, they have to have the sum of 7. So when we're looking at 12, we can say 1 times 12 is 12, but 1 plus 12 is not 7. 2 times 6 is 12, but 2 plus 6 is not 7. 3 times 4 is 12, and lo and behold, 3 plus 4 is 7. So it's very specific to the sum we say, which is that b value, or our product, which is our c value. So keeping in mind, 3 times 4 is 12, 3 plus 4. And the signs are very critical. Once you've determined what those numbers are that represent the sum and represent the product, we set up two bubbles, so double bubble. The variable of our trinomial is the first term in each bracket, so x, And then we can input the two numbers we came up with that satisfy the sum and satisfy the product. So it would be x plus 3 plus 4. Or the order does not matter. You can put x plus 4 and x plus 3. So again, keeping in mind, this is my B, this is my C. So in a simple trinomial, again, we're thinking of two numbers added together to give you -8, the sum, and two numbers multiplied together to give you the product, which is 15. So always begin with your product. 1 times 5 is 15. That doesn't work. 2 does not have 15 doesn't have a factor of 2. 3 times 5. Now looking at the sum, our sum has to be negative. So if your product is positive and your sum is negative, you know that the two numbers have to be negative. So when we're looking at -5 and -3, negative times a negative is positive. If you take -5 plus -3, you are going to get that sum of -8. So with a simple trinomial, we set up our two brackets, so double bubble, and then we place, in our case, the polynomial. The terms used are x, and then we input those two numbers we came up with that satisfy the product and the sum, which are -5 and -3. Or again, like I said, the order doesn't matter because with any multiplication expression, it doesn't matter the order. The signs are critical. And again, the two numbers that we come up with must satisfy the sum and it must satisfy the product. Okay, looking at C, again, the B value is 7 and the C value is 12. So thinking of two numbers added together to give you that sum, which is that B value, and those same two numbers multiplied together to give you that C value, the product. Okay, so again, we've used this number before, but we know 3 times 4 is 12 and 3 plus 4 is 7. So we create the double bubble. Now this time we have two variables. And again, x would be the first term in each bracket, y would be the second term, and then we input those two numbers, +3, +4. The order doesn't matter. So if you wanted to put x plus 4y, x plus 3y, the order doesn't matter. The numbers are critical. They must satisfy the sum, and those same two numbers that you come up with must satisfy the product. Okay, the third method is when we're factoring complex trinomials. When factoring complex trinomials, check for common factors first. If it can be turned into a simple trinomial, because that's what you want to, because a lot of times it's just a common factor, and all of a sudden we're dealing with a simple trinomial. You would like that. Otherwise, we have to use another method called decomposition. Now, for example, we have a 4x squared minus 20x plus 24. Always look for a common factor. So in this case, the common factor between 4, 20, and 24 would be 4. So let's do that first. If we factor out the 4, we're left with x squared. -20 divided by 4 is -5x. 24 divided by 4, which is +6. Look at that. It was an embedded simple trinomial. All we had to do was factor out the common factor of 4. So in this case, the middle term is my sum, and the last term is my product. Thinking of two numbers multiplied together to give you +6, those same two numbers added together to give you -5. So we know when the product is positive and the sum is negative, both numbers have to be negative. So in this case, we can say -3 times -2 is -6. -3 plus -2 is -5. So we leave the 4 out front, create our double bubble. X is the first term in each bracket, and the two numbers came up with was -3 and -2. Again, the order does not matter. Looking at B, we have 2x squared minus 5x minus 3. We have to look to see if we have a common factor. We don't. There's not a common factor between 2, 5, and -3. Now we have something called a complex trinomial. And the difference is, if you notice, in front of the x squared, it's no longer the number 1. There is a number 2. So in this case now, my product is A times C. And my sum is equal to B. So now we have to think of two numbers added together to give you that sum of -5. Okay. And our two numbers multiplied together to give me the product of 2 times -3, which is -6. Okay, so keeping in mind, this would be the middle term is my sum. This is going to be A times your C. Keeping in mind, this is ax squared plus bx plus c, complex trinomial. So thinking of two numbers multiplied together to give you -6, those same two numbers added together to give you -5. Now, if the product is negative, then we know one of the two numbers has to be negative. So in this case, we're going to start with 1 times -6 is -6. 1 plus -6 is -5. So because we are factoring using decomposition, to decompose something means to break it down. So what we need to do is break down the middle term. So with that, we're going to keep the first term, and we're going to decompose the middle term into the two numbers we came up with. So -5x can be broken down into positive x minus 6x. Now keep in mind, I did not change the question. I just broke down that middle term into the two terms we came up with that satisfied the sum and the product. -5. If you took positive x minus 6x, you will get -5x. But by breaking down that middle term, so decomposing it, we've created a situation where we can group the first two terms and group the second two terms to come up with a common factor. So again, sum is the middle term, product is A times C. So 2 times -3 is the product of -6. The sum is -5. The two numbers that satisfy the product of -6 is 1 times -6, which also satisfies the sum 1 plus -6, which is -5. You decompose, and that's why a complex trinomial to factor, you have to do so by decomposition. It's a method we use in order to fully factor a complex trinomial. You break down the middle term into those two terms, so 1x minus 6x, and then you group the first two. Now, the order, again, does not matter. You will end up with the same factors in the end. You group the first two, group the second. I like to use a little down brackets to remind myself I'm grouping the first two terms. So with that, I come up with the common factor of x between my first two terms, and I factor x from 2x squared and x, and I'm left with 2x plus 1. Now, that's kind of a trigger so that you know I have to make sure that I end up with a common binomial factor between those two groups. I need to make sure my brackets I end up with 2x plus 1. So what do I have to divide out of -6x and -3 for that to happen? Well, a common factor between those two would be -3. If I factor out a common factor of -3, I'm left with 2x plus 1. By doing that, I've just created a common binomial between my two groups. They both groups have a binomial of 2x plus 1. So then I would create my double bubble. The common factor of 2x plus 1 would be the first binomial. And then I would, in my second binomial, I would have the common factor of, once I factor out that common factor, I'm left with x minus 3. And let's try that with C. Again, it's a complex trinomial. I first check to see if there is a common factor, because sometimes we have a simple trinomial embedded. So by factoring out the common factor, we check to see that first. In this case, unfortunately, we do not have a common factor. So again, this is a complex trinomial, ax squared, because a is something other than 1, plus c. Okay, so we're thinking of two numbers added together to give us our middle term, which is b, 13, and then two numbers multiplied together to give me AC, so 6 times -5, which is -30. So keeping in mind, this is my product, A times C, and this is my sum, which is equal to B. Okay. So if we look at two numbers multiplied together to give it -30, those same two numbers added together to give you 13. Now, it's tricky because you think, oh, 3 times 10 is 30, but 3 plus 10 is 13. But our product is -30, so that wouldn't work for us. We need to make sure it's two numbers multiplied together to give me -30, added together to give me positive 13. So with that, it would be positive 15 and -2, because 15 times -2 is -30, and 15 plus -2 is positive 13. Now, because it is a complex trinomial, we do have to factor by decomposition. So 6x squared plus 15x minus 2x minus 5. Again, the order does not matter. Then we group our first two and we factor out a common factor between the groups. A common factor between 6x squared plus 15x would be 3x. If we factor out a 3x, 6x squared divided by 3x is 2x. 15x divided by 3x is positive 5. Now, with that in mind, we're looking to make sure we end up with a common binomial factor between our two groups. So that should kind of prompt you to know that if I need 2x plus 5 to be inside my bracket, it has to be a positive 2x and a positive 5. What must I factor out of negative 2x and negative 5 for that to become positive? So you always have to factor out something. In this case, we would have to factor in a -1 so that I'm left with 2x plus 5, because negative 2x divided by -1 is positive 2x. Negative 5 divided by -1 is positive 5. So then, setting up our double bubble, the common binomial factor we know is 2x plus 5. So that's the terms in my first bracket. And then in our second bracket, we would have 3x minus 1. Excellent. Moving on. How do we factor a perfect square trinomials? Now, again, we're looking for a pattern here. When factoring perfect square trinomials, check if the coefficient of x squared and the constant are perfect squares. So recap, what is a perfect square? A perfect square means something multiplied by itself twice will give me that answer. So perfect squares in numbers include 4, because 4 can be expressed as 2 times 2. Okay, another way of looking at it is if you take that term and if you take the square root of it, you would end up with the whole number. Okay, so in our example here, we have a squared x squared plus 2abx plus b squared. We're looking for that pattern. If we can identify that the first term in our trinomial is a perfect square. So is x squared a perfect square? Is there a term or a variable multiplied by itself twice to give me x squared? Absolutely. That would be x to the power of 2. Is the last term a perfect square? So let's look at 25. Is that a perfect square? Absolutely. Now, the other condition that has to exist for this to be a perfect square trinomial is that the middle term has to be 2 times those roots of a and c. Let's see, 2 times x times, so I meant to write 5 and I wrote 10 by accident. 5, is that equal to 10x? It absolutely is. So this would be a binomial squared. What are the terms of my binomial? We would take the x, we take the 5, and we take the sine of our middle term. So therefore, this would be x plus 5 all squared. Right? And a quick way of checking is just expanding it, as we talked about before. Factoring is expressing your polynomial as a product. Expanding would be the opposite. So if I wanted to check x plus 5 all squared is the same thing as x plus 5 times x plus 5. If I wanted to expand that, we know using FOIL, first outside, inside, last, x squared, so x times x is x squared, plus 5x plus 5x plus 25. So I fully expanded. Bring together my like terms, I would end up with x squared plus 10x plus 25. They are equivalent. One is shown expanded, one is shown as factored. Okay, so this is a special case, and we always want to look for or whether the first term and the last term. So the coefficient in front of x squared should be a perfect square, and the constant should be a perfect square. The middle term should always be 2 times their roots. So let's break that down. So let's identify, is the first term a perfect square? Yes, it is, because 2x times 2x would give me 4x squared. Is the last term a perfect square? Yes, it is. 3 times 3 is 9. Is the middle term, and this is the key, this has to exist as well, is the middle term double the roots? And let's see. Well, 2 times 2x times 3 is negative 12x. Therefore, we would have a binomial square. 2x and 3 are the terms of my binomial, and we always keep the sign of that middle term. Okay, again, anything we do in when we factor, always look for a common factor first. So looking at 3x squared plus 30x plus 75, we do have a common factor of 3. X squared plus 10x plus 25. Okay, with that in mind, we now check to see, do we have a perfect square trinomial? Let's see. Is this x all squared? It sure is. 5 all squared, that's also perfect square. Now again, the condition has to exist. The middle term has to be 2 times their roots. Well, 2 times x times 5 is 10x. Therefore, we can say, we can factor that perfect square trinomial as a binomial of x plus 5 all squared. Okay, moving on. Difference of squares. So another factoring method, difference of squares. When factoring a difference of squares, a binomial difference of perfect squares, take the square root of the first and the last term. Now this one's a little bit easier to identify only because you have two terms. They're both perfect squares, so it's a binomial, and there's a difference between them. Okay, so let's first identify, do we have a difference of squares? Is the first term a perfect square? X times x is x squared. Is 64 a perfect square? Well, yes, it is. 8 to the power of 2, 64, 8 squared. Now, if that is the case, we set up our two brackets, so a double bubble. X would be the first term in each bracket because it's the first perfect square. 8 in the second bracket. And then the only difference between the two brackets are our signs. The order does not matter. Or if you wanted to write x minus 8 x plus 8, it does not matter. Okay, so you always want to identify, is this a difference of squares? Okay, looking at B, 7 squared is 49. Yes, 7 times 7 is 49. Is 16y squared a perfect square? Absolutely. So 4y to the power of 2 is a perfect square. 4y times 4y is 16y squared. Once we identify it's a difference between them, the first term in each bracket would be 7. 4y would be the second, and the only difference between the two are the signs. So positive in the first, negative. So it has to be those different signs. Or if you wanted to put the difference first, that's fine. Then in the second bracket would be the addition. Okay, looking at C, we have, again, have to identify it's two different terms. One's the expression with the first, subtract 9 as a perfect square. So keeping in mind, this is the same thing as 2 times 2x minus 5 all to the power of 2 minus 3 to the power of 2. Now, even though it's an expression in the first difference of squares and the second one is just a single term, it still qualifies as a difference of squares. So with that in mind, you still set up the two brackets. In the first bracket, we'd have 2x minus 5 as the first expression, 3 as the second, and the difference between them is their sign. Now, we always say we have to always simplify fully. So with each of these brackets, we would expand. So use the distributive property to get rid of those brackets. And 2 times 2x, which is 4x. 2 times negative 5, which is negative 10, plus 3. 2 times 2x, which is 4x, minus 10, minus 3. And of course, we simplify, collect like terms. 4x negative 10 plus 3, which is negative 7. 4x negative 10 minus 3, which is negative 13. Okay, so the last method of factoring is factoring by grouping. For polynomials with more than 3 terms, try grouping similar terms, possibly using a combination of the previous methods. Okay, so this only happens when you have, say, 4 terms, and sometimes you have to be creative. So for the first one, looking from left to right, I think if we grouped our first two and we grouped our last two, okay, let's see if there's something common between them. So looking at the first two terms, x, y, and 6x, they have a common factor of x. And if I factor that out, I'm left with y plus 6. Looking at the second group between 5y and 30, a common factor there is a positive 5, and we're left with y plus 6. If you notice, now we've created a common binomial between the groups. So similar to when we were using decomposition, we know y plus 6 is common, and then we're left with x plus 5 to go into the second bracket, because that would be our common factor. So sometimes we can't see that, but you're following the same idea. If you divide this by y plus 6, and you divide that by y plus 6, that would be common, and therefore we're left with x plus 5. Okay, looking at B, we have 5x cubed plus 5x squared plus 6x plus 2. So let's see, even if we just go from left to right, we're going to group our first two, group our second two. Looking at 5x cubed plus 5x, we are going to find a common factor of 5x squared. If you factor out a 5x squared, we're left with 3x plus 1. Keeping in mind, we want to make sure that when we factor something out of 6x plus 2, we should come up with that common binomial 3x plus 2. So factoring at a positive 2, we're left with 3x plus 1. So now we have a common binomial. We set up our two brackets. 3x plus 1 is common, so we're left with 5x squared plus 2 in our second bracket. We're done. Looking at C, if we group the first two and we group the last two, we wouldn't have a common binomial factor between the groups. Okay, and a squared and b squared don't have anything common. We'd only have something common between 25 and 10. But if we rearranged a squared plus 10a plus 25, and we subtracted b squared, we then create something called a perfect square trinomial over here, which will help us factor that as a binomial square. So that's a perfect square trinomial. How do I know that? I'm going to quickly remind you. A all squared plus 5 all squared, and the middle term is 2 times a times 5, that 10a. So if I group this, minus b squared. A perfect square trinomial can be factored as a binomial square. So this would be a plus 5 minus b squared. By doing that, I've created a difference of squares. So with that, I can create my two brackets. A plus 5 would be the first expression each bracket, and then b would be the second, and the only difference between them is a plus and a minus. The order does not matter. And then, of course, we want to fully simplify a plus 5 plus b, and this would be a plus b, a plus 5 minus b. A plus 5 minus b. And of course, we like to make sure it's expressed in decreasing order. So a plus b plus 5, a minus b plus 5.